So hi guys, welcome. Today I'm going to be talking about the urinary system. As you can see in the kidney in the given slide, in this specific organ, this can consist of parts like glomerulus. Here is a closer look at the region. We have the efferent arteriole at the left side, going towards the glomerulus, and the efferent arteriole going away from it. In the bottom consists of the nephron, where the fluid coming out is a filtrate, which will eventually become urine after being heavily modified. Now, after it goes through the efferent arteriole, it proceeds into a capillary bed that contains oxygenated blood, then into peritubular capillaries that feed the kidney with nutrients and oxygen. In this capillary, once oxygenated blood comes out, it then becomes deoxygenated blood. Then enter the venous system, which head back to the heart. Now, the path of venous blood getting back out of the artery mirrors the path of arterial blood coming into the kidney. Bigger vessels then join and become a renal vein. This finally leaves the kidney. Moving on to discuss the types of urine formation, we will first proceed to step number 1. First, liver cells metabolize amino acids and release urea into the bloodstream. Then we have filtration that leaves blood cells and parts that are considered to be large in the bloodstream, while urea, glucose, ions, and other types of solutes are to be filtered at the nephron. Next, reabsorption comes, which returns useful materials like ions, water, glucose, and amino acid back into the collecting duct of blood and its nephron. After that comes the secretion stage, where secretion of toxic substances into the nephron occur to be eliminated by urine like ions and other types of surplus ions. Finally, after reabsorption and secretion, it is released by urine, which is a mixture of water, urea, toxins, and ions. We have 3 main mechanisms in the urinary system. First is the buffering system, which is the first line of defense, which its main player is the bicarbonate and carbonate buffering system, and other players like protein buffer system, which is in charge of the primary intercellular field. Next player is the hemoglobin buffer system, which attaches to the hydrogen ions and is very important against carbonic acid. In this structure, the bicarbonate HCO3 will attach with hydrogen and give carbonic acid. This buffering system brings back the pH to normal if it is ever too high or low. Another mechanism is the respiratory compensation, the second line of defense. As you can see, this is the structure. When arterial hydrogens increase, the rate of breathing also increases, which in the structure moves to the left. When arterial hydrogen ions fall, pulmonary ventilation also decreases, which in the structure moves to the right. Now, there are 2 types of receptors that cause it to work between radios. The peripheral chemoreceptors that respond to the hydrogen ions, and central chemoreceptors that respond to carbon dioxide. These are what speak if concentration of CO2 or hydrogen is too low or high. Last but not least is the last line of defense that takes hours or even days to work. This is what we like to call the renal competition. This system adjusts 3 factors. First, the hydrogen excretion, second, the bicarbonate excretion, and lastly, ammonia secretion. And to provide some details, this is a task of eliminating hydrogen ions derived from sulfuric, phosphoric, lactic, and other acids left with the kidney. The main player of this task is the kidney that excretes hydrogen ions and results to urine pH being 6.0. Since this is lower, this means that it has more hydrogen ions. The neutral level of pH is 7.35 to 7.45. If it is above 7.45, it is alkalosis. This can cause muscle spasm, numbness, confusion, and many other more. Alkalosis develops when the body loses too much acid or gains too much base. If it is below 7.35, it is acidosis. This can lead to seizure, coma, and excess vomiting. That is all for today. Hope you learned something.